Everyone, and welcome to the lecture on cluster maps. As usual, we start by importing the libraries and modules that we need. Import NumPy, Pandas, Seaborn, and Matplotlib's pyplot, and we have the special function that will allow us see our graphs on Jupyter Notebook. We'll be using the flights dataset for this lecture. Let's start by loading our flights dataset, and we'll save it in a variable called flights. We'll use Seaborn's load dataset function. So sns.load dataset, and we'll pass the flights dataset. So if I call the flights head method, we have year, months, and passengers. Similar to what we did with heat maps, we'll pivot our flights dataset so that we can use it nicely for our cluster map. So we'll pivot our flights data and then save it in the same flights variable. So we have flights dot pivot. We'll call the pivot function, and we'll pass months, year, and number of passengers. So we'll have months and year on the row and column, and each of the cells in our cluster will show passengers. Before I proceed to cluster map, let's see a heat map on our flights dataset. So SNS, we can simply call the heat map method and then pass our flights dataset. If we run this, we have a heat map. We have months and year and number of passengers indicate each of this cluster. Notice here that the years and months are organized in an incremental fashion. So it starts from 1949 to 50, and then it goes to 1960. And the months are also arranged in order from January through December. That's for our heat map. Now let's see our cluster maps. We'll be calling the cluster map function that Seaborn has, and what it does is it will cluster our flights dataset by the months and year so that it puts together similar data. Let's see what it looks like. So we'll call the cluster map method that Seaborn has, and then we'll pass our flights dataset. Let's run it. This is the cluster map, and here you see that it's clustered by both months and year. So it's clustered by both of those variables. And you see here that both the rows and columns are out of order. For instance, if you consider the years here, it goes from 1949 to 50, and then 53, 54, 51, 52. So it clusters together similar data. And same thing for the year, the months. It clusters together similar months. So it's not in order. You see here you have September, June, August, and July. It clusters together similar months. And here it clusters together similar years. Okay, that's cluster map. We cluster our data set by both the rows and columns. In this case, by both months and years. We can also pass some other attributes. And for instance, let's say we want to cluster only either the row or column. For that, we'll pass some other attribute that will allow us to cluster either the row or the column. Let's say we want to cluster the rows only. If we want to cluster the rows only, we'll pass an attribute known as column cluster, and then we'll set that attribute to false. Let's see an example. So sns.clustermap, and we'll pass the flights dataset, and then we'll pass an attribute known as column cluster, and we'll set it to false. So this way we'll only cluster the rows. So if we run this, now we see that only the rows are clustered. So it's clustered by menses only. So data for similar menses are clustered together. Okay, so you see here the menses are out of order, whereas the year is in order, since we only clustered the rows. Similarly, we can also cluster columns only. For that, we'll pass the row cluster and set it to false. Let's see what that looks like. So sns.clustermap, and then we'll be using the flights dataset, and for row cluster we'll set it to false. If we run this, now it's clustered by columns only. That means it clusters together the years only. So here you see the years are out of order, whereas the months are in order. January, February through December. Now you see similar columns are clustered together, right? So again, we can use this key to obtain information about the number of passengers. So the darker colors have passengers closer to 600. So from this graph, from this cluster map, you can say that we have the most number of passengers in the year 1959 and 1960. It makes sense, right? And if you consider the months, you can be specific and say during the months of July and August, we have the most customers from 1959 to 1960. And the same applies to any of the cluster maps we have seen so far. So for instance, here you get the same information. We have the most customers in July and August in the years 1960 and 1959. If we go to our first cluster map, we get the same information, right? And we have the least customers here in the months of January and February, and in the years 1940 and 1950, then 1951, 1952, and so on. We can follow this key to compare the number of passengers for a given month or year. Another thing we can do is change the color of our cluster map. For that, we'll pass the color map attribute. Let's see an example. So sns.clustermap, we'll be using the flights dataset. And then for color map, let's pass cool warm maybe. So color map. Let's run it and see. Oh, nice. So we have clustered our data by columns and rows. And here is the key for our cluster map. So towards red, we have the highest number of customers, which is in August and June. And we have the least number of customers towards the dark blue color, which is in the years 1949 and 1950. We can also add line widths to our cluster maps. For that, we'll be passing the line width attribute. And let's add a line width of 1 maybe. Let's see what it looks like. Now we have separate cluster maps. It looks nicer. And you can pass some other color maps and line widths. Let's change this to maybe blues underscore R, and let's change the line width to 1.4 and run it. So now we have a different shade. The keys will always be there for your reference. See, now the lighter colors have the highest number of passengers. That's what we see here for July and August. And we have each of our separate clusters. So you can use those attributes to change the style and appearance of your cluster maps.